Normandy, France. July 1944. A German Panther tank commander scans the hedgerow-lined roads through his periscope. His 75mm gun, one of the finest tank weapons in the world, sits silent. He's confident. The Panther can penetrate a Sherman from over a mile away. American tanks? They have to get close. Very close. Then he sees it. 300 meters ahead. An American M4 Sherman, moving at 15 miles per hour across the field. The German commander smirks. They're moving. They won't hit anything. In tank warfare, there was an ironclad rule that every tanker on every side knew by heart. You stop to shoot. Moving tanks couldn't hit targets. The vibration, the terrain, the barrel whip, it was impossible. You found your target, you stopped, you aimed, you fired. That's how tank combat worked. The German gunner tracks the Sherman. He's waiting for it to stop. That's when they'll strike. But the Sherman doesn't stop. The American tank fires on the move. The German commander barely has time to process what he's seeing before the 75mm round slams into his Panther's thinner side armor. As his crew bails out, one thought dominates his mind. How did they hit us while moving? Today, we're uncovering one of World War II's most underrated technological advantages. A secret that American tankers carried into battle, but German tankers didn't discover until it was far too late. This is the story of the gyroscopic stabilizer, the innovation that let American Shermans do what German Tigers and Panthers physically could not: fight effectively while moving. And it changed armored warfare forever. To understand why the gyro-stabilizer was revolutionary, we need to understand the fundamental problem that plagued every tank in World War II. Tank guns in the 1940s were incredibly powerful weapons. The German 88mm on the Tiger could penetrate over 4 inches of armor at 1,000 yards. The American 75mm could punch through 3 inches. These were devastating weapons. But they had one critical weakness. They were mounted on vehicles bouncing across rough terrain at speeds up to 25 miles per hour. Imagine trying to thread a needle while riding a galloping horse. That's essentially what tank gunners faced. Every bump in the road translated directly to the gun barrel. Hit a rock? The barrel jumps 3 degrees up. Cross a ditch? 2 degrees down. Turn slightly? The barrel swings left or right. At 300 meters, a typical engagement range, a 3-degree shift means your shell lands 15 feet away from your target. At 1,000 meters, 50 feet off target. And here's the critical point. In tank versus tank combat, you're not shooting at a barn. You're shooting at a target roughly 8 feet tall and 20 feet wide. Missing by 15 feet means a complete miss. Every nation fighting in World War II faced this same problem. The German solution was Doctrine: halt, identify, engage. German tank manuals were explicit. Panzer commanders were trained to stop their vehicles, let the suspension settle for 2 to 3 seconds, acquire the target, and then fire. The Soviet solution was similar, though Soviet doctrine emphasized closing to point-blank range where accuracy mattered less. The British experimented with various solutions, including the Vickers stabilizer in some tanks, but implementation was limited and often unreliable. The Japanese barely addressed the problem at all. Their tanks were primarily infantry support vehicles, not designed for tank versus tank combat. But the Americans took a different path entirely. They decided to break the fundamental rule of tank combat. They decided to shoot while moving. And to do that, they needed technology that, in 1940, seemed almost impossible. The birth of the stabilizer. The story begins not on a battlefield, but in a laboratory at the Watertown Arsenal in Massachusetts. The year was 1935, 4 years before World War II even began. The U.S. Army Ordnance Department had identified a problem. American tanks were becoming faster and more mobile, but their gunnery accuracy hadn't improved. An officer named Colonel John K. Christmas proposed a radical solution. What if the gun could stabilize itself? The concept wasn't entirely new. Gyroscopes had been used in ships and aircraft for stabilization. The German Navy had used gyroscopic systems in their fire control as far back as World War I. But a tank presented unique challenges. Ships moved relatively smoothly. Aircraft had three-dimensional freedom of movement that could be predicted. But a tank? A tank experienced violent, rapid, unpredictable movements across broken terrain. The Westinghouse Electric Corporation took on the contract. Their engineers, led by a brilliant team of designers, faced an enormous challenge. They needed to create a system that could detect when the gun barrel moved off target, calculate the correction needed, apply that correction instantly, do all of this while the tank bounced across a battlefield, be reliable enough for combat, be simple enough for a tank crew to operate under fire. The solution they developed was ingenious. At its heart was a gyroscope, a rapidly spinning wheel that naturally resists changes to its orientation. This gyroscope was connected to the gun mount. When the tank's hull moved, the gyroscope detected the difference between where the gun was pointing and where it should be pointing. That information fed into an electric motor system connected to the gun's elevation mechanism. Within a fraction of a second, the motor would adjust the gun barrel to compensate for the hull's movement. The result? While the tank bounced and rolled across rough ground, the gun barrel remained locked on target. By 1938, Westinghouse had a working prototype. By 1940, as war engulfed Europe, the system was being tested in American tanks. By 1941, the Ordnance Department made a decision that would echo across every battlefield in Europe and the Pacific. The gyroscopic stabilizer would be standard equipment in the M4 Sherman medium tank, not an optional upgrade, not a special feature for elite units. Standard equipment. This decision meant that every Sherman tank rolling off American production lines, and there would be 49,234 of them, would have a capability that no German, Soviet, or Japanese tank possessed. German intelligence would eventually learn about the stabilizer's existence. But knowing about it and experiencing it in combat were two very different things. How the stabilizer actually worked. Let's get technical for a moment, because understanding how this system worked helps us appreciate just how remarkable it was. The Westinghouse stabilizer installed in Sherman tanks was officially designated the Combination Gun Mount M34 for the 75mm gun, and later the M62 for the 76mm gun. The system had several key components. First, the gyroscope itself. This wasn't a small device. The gyro rotor weighed about 30 pounds and spun at approximately 9,000 revolutions per minute. It was housed in a protective case and mounted in the turret. Second, the amplidyne control system. This was essentially an electric amplifier that took the weak signal from the gyroscope and converted it into enough power to move the gun. Third, the elevating mechanism. Electric motors connected to the gun's elevation gears, capable of moving the gun barrel up or down at variable speeds. Fourth, the power source. The entire system ran off the tank's 24-volt electrical system, drawing power from the engine-driven generator. Here's what happened when a Sherman crew engaged a target while moving. The gunner would spot a target and center his crosshairs on it. He'd flip a switch on his controls, engaging the stabilizer in the vertical plane, meaning the gun would maintain its up and down angle. As the Sherman moved forward, the hull would pitch up and down over rough terrain. Without stabilization, this would cause the gun barrel to point at the sky 1 second and the ground the next. But with the stabilizer engaged, the gyroscope detected these movements instantly. As the hull pitched up, the stabilizer would automatically adjust the gun downward to compensate. As the hull dropped into a depression, the stabilizer would raise the gun to maintain the aim point. The gunner still had to handle horizontal traverse, turning the turret left or right, manually. But keeping the gun on target vertically, which was the bigger challenge over rough terrain, was handled automatically. The system could make corrections dozens of times per second. It reacted faster than any human gunner could. Testing showed that a Sherman with the stabilizer could maintain accuracy while moving at speeds up to 15 miles per hour over moderately rough terrain. Without the stabilizer, accuracy while moving was essentially zero. But here's where it gets interesting. The technology was only half the equation. American tank crews had to be trained to trust the system and use it effectively. Many crews, especially early in the war, were skeptical. The stabilizer made a humming noise. It drew electrical power. Some crews worried it would fail at a critical moment. And honestly, some crews never fully embraced it. But the crews that did, the ones that trained with it, trusted it, and incorporated it into their tactics, gained an enormous advantage. An advantage that German tankers literally couldn't understand when they first encountered it. German tank doctrine stopped to shoot. While American engineers were perfecting the stabilizer, German tank doctrine was being written in the campaigns of Poland, France, and Russia. And that doctrine was built on a simple principle: superior German tanks, superior German optics, superior German gunnery. The Germans had good reason for confidence. The Panther tank, introduced in 1943, had a 75 mm gun that could penetrate a Sherman's frontal armor from 2,000 meters. The Sherman's 75 mm struggled to penetrate a Panther's frontal armor even at 500 meters. The Tiger I, with its legendary 88 mm gun, could kill a Sherman from over 2 kilometers away. Its frontal armor was effectively immune to the Sherman's 75 mm at most combat ranges. German optics were superb. Zeiss-manufactured gun sights gave German gunners crystal-clear views of the battlefield. German rangefinders were more accurate than American ones. And German gunnery training emphasized precision. German gunners practiced for hours on recognizing targets, calculating range, and making that crucial first shot hit. German tank doctrine, refined through years of combat, followed a pattern. First, spot the enemy. German tank commanders typically fought with their heads out of the hatch, giving them better situational awareness than buttoned-up opponents. Second, halt the tank. The driver would stop, and the entire crew would wait 2 to 3 seconds for the vehicle to settle. Third, the gunner would acquire the target through his sight, the commander would call out range and corrections, and the gunner would make fine adjustments. Fourth, fire. One shot, one kill was the goal. If the shot missed, the process would begin again. Adjust, settle, fire. In the open terrain of North Africa and the steppes of Russia, this doctrine was devastatingly effective. German tanks could engage at ranges where Allied tanks couldn't effectively return fire. They could take their time, set up the perfect shot, and destroy enemy tanks before those tanks even got close enough to be a threat. A Tiger tank in a defensive position, hull down behind cover, was almost invulnerable. It could methodically pick off Allied tanks one by one. German tankers assumed that everyone fought this way because everyone had to fight this way. The physics of tank gunnery demanded it. You couldn't hit anything while moving. That was just a fact of armored warfare. Or so they thought. But in the hedgerows of Normandy, the forests of Belgium, and the rubble of German cities, the rules were about to change. The Americans were bringing a different kind of tank warfare. And German tankers were about to discover that some of their most fundamental assumptions were dead wrong. June 6, 1944. Omaha Beach. The first Sherman tanks rolled off landing craft into waist-deep water, struggling through obstacles and enemy fire to reach the beach. These tanks weren't thinking about gyro-stabilizers. They were thinking about survival. But within days, as American armored divisions pushed inland from the beaches, the stabilizer would begin to prove its worth in the most challenging terrain imaginable, the Norman bocage. If you've never heard of bocage, imagine this. Centuries-old hedgerows, some dating back to Roman times, dividing the French countryside into a patchwork of small fields. These weren't garden hedges. They were massive earthen banks, 5 to 10 feet high, topped with dense vegetation and trees. Visibility was measured in dozens of yards, not hundreds. Roads were narrow, sunken lanes with hedgerows on both sides, perfect ambush sites. For German defenders with Panzerfaust anti-tank rockets and dug-in tanks, it was paradise. For American tankers, it was a nightmare. In Bocage country, tank combat happened at close range and fast. You'd round a corner and find a German Panther 50 meters away. Or you'd be crossing a field and take fire from a concealed PZK-PFW-4 in the hedgerow. There was no time for the methodical German approach. Halt, settle, acquire, fire. Combat happened while moving or not at all. Lieutenant Charles Spohr, a Sherman tank commander in the 2nd Armored Division, described an engagement in his after-action report. We were moving down a lane at about 10 miles per hour. My driver spotted a Panzer IV's barrel poking through a hedgerow on our left. I couldn't stop. There was a Sherman behind us and no room to maneuver. I told my gunner to engage while we kept moving. He stabilized the gun, tracked the target, and fired. We hit them on the second shot while still rolling. The Panzer never got a round off. This pattern repeated itself across Normandy. American Shermans engaging while moving. German tanks trying to stop and set up shots but being hit before they could fire. German after-action reports from Normandy show genuine confusion. One Panther commander reported, "American tank fired while advancing at speed. Hit our position with first round. This should not be possible." Another report, from a Tiger company in the Panzerlehr Division, noted, "Enemy tanks demonstrate unusual accuracy while moving. Suspected elite unit with exceptional training." They weren't facing elite units. They were facing standard American armored divisions. But they were facing the stabilizer. Now, we need to be clear about something. The stabilizer didn't make Shermans invincible. Far from it. German tanks still had better guns and better armor. In a static, long-range duel, a Tiger or Panther still had the advantage. But in the close-quarters chaos of Bocage fighting, the stabilizer tilted the odds. An American Sherman could fire effectively while moving at 15 miles per hour. A German tank had to stop, and stopping in Bocage country, even for 3 seconds, meant being a stationary target. American tank commanders quickly learned to exploit this advantage. They developed a tactic called marching fire, keeping the gun stabilized and firing at any suspected enemy position while advancing. The first round might miss, but it would suppress the enemy while the Sherman kept moving to a better position. They learned to never stop in the kill zone. Keep moving, keep the stabilizer engaged, get to cover, then stop and engage properly if needed. Some crews developed remarkable proficiency. Sergeant Lafayette Poole, a Sherman tank ace with 12 confirmed tank kills, was known for his ability to hit targets while moving at full speed. By late summer 1944, German intelligence had identified that American tanks had some kind of stabilization system. A captured Sherman was extensively examined. German engineers studied the gyroscope mechanism and wrote detailed reports about its capabilities. But knowing about it and countering it were different things. German tank factories were already operating at maximum capacity, trying to replace losses on 2 fronts. The resources and time needed to develop and install their own stabilization system simply didn't exist. German tankers would have to fight American Shermans without this technological advantage for the rest of the war. And as the war moved into the fall and winter of 1944, the fighting would only get more intense. The battles where it mattered most. The stabilizer proved its worth in 3 types of combat situations. Let's examine the battles where this technology made the biggest difference. September 1944, Héricourt, France. The Battle of Héricourt is considered one of the greatest American tank victories of World War II. The 4th Armored Division destroyed over 200 German tanks and assault guns while losing only about 25 Shermans. Weather was terrible: rain, fog, mud. Visibility was poor. Engagements happened suddenly at close range. Captain James Leach, commanding a Sherman company, reported encountering a column of 5 Panthers moving through fog at 200 meters range. His Shermans were moving perpendicular to the German column. In traditional tank doctrine, both sides should have stopped to engage. But Leach's Shermans didn't stop. They engaged with stabilizers active while continuing to move. We hit 3 of them before they even realized what direction fire was coming from, Leach reported. By the time they stopped and oriented on us, we'd already knocked out their lead and trail tanks, boxing in the column. The Panthers, caught in column formation and unable to effectively return fire while stationary in the mud, were systematically destroyed. This wasn't a fluke. It happened repeatedly at Aracourt. American Shermans using mobility and stabilized fire to overwhelm technically superior German tanks. November 1944. Metz, France. Urban combat presented unique challenges. Streets were narrow. Buildings provided cover but also concealment for enemy anti-tank teams. Tanks had to keep moving to avoid being hit by Panzerfaust. Sergeant Joseph Sadowski described fighting through Metz. You couldn't stop. Stop and you'd get a Panzerfaust in your side. We learned to move fast through intersections, with the gunner tracking his sector with the stabilizer on. If you saw a threat, a window, a doorway, an alley, you fired while moving. We probably fired more rounds while moving than while stopped in that whole battle. The Germans, using dug-in assault guns and Panthers to support their infantry, tried to fight from static positions. But American Shermans moving rapidly through the streets, firing on the move, gave German gunners very little time to acquire targets. March 1945, Remagen Bridge. When American forces captured the Ludendorff Bridge at Remagen intact, it opened a pathway into the heart of Germany. But the bridgehead needed to be expanded rapidly before German forces could contain it. This meant American armor had to advance quickly over broken, contested terrain while engaging any German forces that tried to establish defensive positions. Lieutenant Colonel William Prince, leading an armored task force, described the breakout. Speed was everything. We couldn't afford to get bogged down in firefights. The doctrine was simple. If you see it, shoot it, but don't stop. The stabilizer let us maintain fire superiority while advancing. German positions that would normally slow in advance, a PaK-40 anti-tank gun, a dug-in tank destroyer, we could engage and suppress while barely slowing down. Within a week, American forces had expanded the Remagen bridgehead to a depth of 10 miles. The stabilizer wasn't the only reason, but it was a significant factor. Statistical analysis of American tank combat in Northwest Europe shows some interesting patterns. Shermans that engaged while moving had a first-round hit rate of approximately 30 to 40% at ranges under 400 meters with the stabilizer engaged. Without the stabilizer, hit rates while moving dropped below 10%. More importantly, Shermans using marching fire and mobile tactics had significantly lower loss rates than Shermans fighting from static positions, even though German tanks had better guns and armor. Why? Because a moving target is harder to hit than a stationary one. And if you can shoot accurately while moving, but your enemy can't, you have a decisive advantage. German tactical manuals were eventually updated to warn about American fire-while-moving capabilities. Recommendations included: engage at longer ranges where American tanks would be forced to stop. Use ambush positions to get the first shot. Focus on track mobility kills to stop American tanks. These were sound tactics. But they didn't eliminate the American advantage, they just tried to mitigate it. German tankers fought bravely and skillfully throughout the war. But they were fighting with a fundamental tactical disadvantage that their training and doctrine couldn't overcome. What German tankers said after the war. After the war ended, Allied intelligence teams interviewed hundreds of German tank commanders and crew members as part of debriefing operations. What they learned about German perspectives on American tank technology was fascinating. Otto Carius, one of Germany's most successful tank aces with over 150 tank kills, was interviewed extensively about his experiences fighting American forces in 1945. When asked about American Shermans, he made an interesting observation. The Sherman was inferior to our Tigers and Panthers in almost every measurable way: armor, gun, speed on roads. But in combat, American tankers seemed to operate with a confidence that their technical disadvantages didn't justify. They would advance aggressively, engage while moving, and use terrain in ways that suggested they didn't feel as vulnerable as they should have. When the interviewer mentioned the gyro-stabilizer, Carius paused. We knew they had something. We'd see Shermans firing while moving with accuracy that shouldn't be possible. We assumed it was superior training or perhaps better optics. When I learned after the war it was a mechanical stabilization system, that explained a great deal. Hans von Luck, who commanded armored units in North Africa, Normandy, and the Eastern Front, was even more direct. In Normandy, we noticed immediately that American tanks fought differently than British tanks. The British would typically stop to engage, much like we did. But Americans would fire while moving. At first, we thought they were simply poorly trained, wasting ammunition. Then we realized they were actually hitting targets. We captured a Sherman intact near Cannes. Our technical officers examined it and found the gyroscope system. The report came back. Enemy has stabilization device allowing accurate fire while moving. I remember thinking, of course they do. It explained why our normal tactics weren't working against them in Bocage country. Could we develop something similar? Perhaps, given time and resources. But by 1944, we had neither. Franz Kurowski, who fought in a Panther battalion on the Western Front, provided tactical perspective. The American doctrine was fundamentally different from ours. We were taught, see the enemy, take position, aim carefully, fire precisely. One shot, one kill. It worked brilliantly on the Eastern Front with its open terrain. But against Americans in France and Germany, they would see us and immediately engage while moving. Their first shot might miss, but it would land close enough to suppress us. Dust, smoke, noise. By the time we stopped and acquired them properly, they'd already fired 2 or 3 more rounds. Volume of fire versus precision. With the stabilizer, their fire while moving doctrine actually worked. Without it, they would have been slaughtered. With it, they were dangerous opponents even in technically inferior tanks. Thousands of German tank crew members were interviewed as prisoners of war. A common theme emerged. They respected American tank crews as brave and competent. They appreciated American tanks as mechanically reliable and well-designed. But they were consistently surprised by American tactical aggressiveness and the ability to engage effectively while moving. One Panther driver, interviewed at a POW camp in France, put it simply, "We thought Americans would fight like British, carefully, methodically. Instead, they drove straight at us, shooting the whole way. How do you stop an enemy that won't stay still?" After the war, German engineers examined captured Sherman tanks in detail. A report from the Heereswaffenamt, Army Weapons Office, dated June 1945, analyzed the stabilization system. The American approach represents a different philosophy of armored warfare. Rather than seeking to win through superior vehicle characteristics, they have created a system that maximizes the effectiveness of a mediocre tank through superior fire control and doctrine. The gyroscopic stabilizer is a key component of this system. It is telling that American designers prioritize stabilization over armor or gun power. This suggests they understood that tanks must fight while moving, and that the first tank to score a hit, even with an inferior gun, often wins the engagement. Had we developed similar systems earlier in the war, the tactical situation on all fronts might have been significantly different. Here's the ironic part. Germany had gyroscope technology. They used gyroscopes in their naval fire control systems, their aircraft gun sights, and their V-2 rocket guidance systems. They could have developed a tank gun stabilizer. But they never did. Whether it was because they didn't see the need, or because resources were prioritized elsewhere, or because their doctrine didn't emphasize mobile gunnery, the fact remains that German tanks never got the technology that American tankers used as standard equipment throughout the war. The legacy and impact. The gyroscopic stabilizer in the M4 Sherman wasn't just a tactical advantage in World War II. It fundamentally changed how the world thought about armored warfare. After World War II, every major military power recognized the value of gun stabilization. The Soviet Union developed stabilizers for their T-54 and T-55 tanks, deployed in the early 1950s. Soviet engineers studied captured German reports on American stabilizers and developed their own systems. The British, who had experimented with stabilizers during the war but never fully implemented them, made stabilization standard in post-war tanks like the Centurion. The French, Germans in the new Bundeswehr, and other NATO forces all adopted stabilization technology in their Cold War tank designs. Today, every main battle tank in the world has a stabilized main gun. Modern systems are far more sophisticated than the Westinghouse stabilizer of 1941. They use computer controls, laser gyros, and can stabilize in both vertical and horizontal planes. Modern tanks can fire accurately while moving at 40 miles per hour over rough terrain. They can engage multiple targets while on the move. They can hit targets at 2,000 meters without stopping. This all traces back to that decision in 1941 to make stabilization standard equipment in American tanks. But more than the technology, the stabilizer changed doctrine. Modern armored warfare emphasizes mobility, speed, and continuous movement. The idea of stopping to shoot, the standard practice in World War II, is now considered tactically unsound. A stationary tank is a dead tank. This doctrinal shift was enabled by stabilization technology. Without it, modern armored warfare would look very different. In the context of World War II, the stabilizer gave American tankers an advantage that helped offset the Sherman's technical inferiority to German tanks. Was it the only reason Americans won tank battles? Of course not. American advantages included overwhelming numerical superiority, better logistics and supply, air superiority that devastated German armor, better crew training and coordination, mechanical reliability, superior radio communications. But the stabilizer was part of the package. It was one more advantage that made the Sherman, despite its flaws, an effective combat vehicle. It's worth noting that technology alone didn't win battles. The stabilizer was only effective when crews were trained to use it and trusted it enough to fight while moving. Many Sherman crews never fully utilized the stabilizer. Some found it temperamental. Some preferred traditional stop-and-shoot tactics. But the crews that did embrace it, that trained with it, maintained it properly, and incorporated it into their tactics, gained a significant edge. Could Germany have won the tank war if they'd had stabilizers? Probably not. By 1944, the material and numerical imbalances were too great. But would it have made their defense more effective? Absolutely. German tanks with stabilized guns, fighting from defensive positions with the ability to engage while repositioning, would have been even more formidable than they already were. The fact that they never developed this capability remains one of the curious oversights of German wartime technology development. The gyroscopic stabilizer in the M4 Sherman represents something important about American industrial and military innovation in World War II. It wasn't the biggest weapon. It wasn't the most powerful technology. It didn't win headlines or capture imaginations the way the atomic bomb or the P-51 Mustang did. But it solved a specific problem in a clever way. It took existing technology, gyroscopes, and applied it to a new challenge. It was then mass-produced and made standard equipment in tens of thousands of tanks. That was America's strength in World War II. Not just building the biggest or most powerful weapons, but building huge quantities of good enough weapons with small technological advantages that added up. The stabilizer let American tankers do something German tankers couldn't: fight effectively while moving. That advantage was worth its weight in gold in the hedgerows of Normandy, the streets of German cities, and the forests of the Ardennes. After the war, an American colonel visited a German tank school that was being established for the new Bundeswehr in the 1950s. He watched German instructors teaching tank gunnery using some of the same methodologies from World War II: halt, identify, engage. The colonel mentioned the stabilizer and the American doctrine of firing while moving. The German instructor, a veteran of the Eastern Front, smiled ruefully. Yes, we know. We learned that lesson the hard way. Our new tanks will have stabilizers. We won't make the same mistake twice. That conversation, more than any statistic or technical specification, captures the significance of the gyro-stabilizer. It was a lesson written in combat across the battlefields of Europe. A lesson that German tankers learned too late. A lesson that changed armored warfare forever. The Sherman stabilizer. A technology so subtle that enemies didn't understand it, so effective that they couldn't counter it, and so important that every tank in the world now carries its descendant. German tankers couldn't believe American Shermans were equipped with gyro-stabilizers for firing while moving. By the time they understood what they were facing, it was too late. If you found this video interesting, check out our video on how German U-boat commanders realized America built ships faster than they could sink them, or our deep dive into why German pilots were shocked by the P-51 Mustang's range. Thanks for watching, and we'll see you in the next one.